So which of the following elements would you expect to have the lowest first ionization energy? Now, without going back, right, no cheating, which of these elements in the third row of the periodic table would you expect to have the lowest first ionization energy? Similarly, which element would you expect to have the highest third ionization energy? And if you've paused and answered the question, the lowest first ionization energy corresponds to the element that can easily lose one electron. This will be an element that just has one single valence electron, and if we observe the list, ding, 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 sodium is going to be the winner. Now we can go back to the successive ionization energy table to confirm this, which we'll do in a moment. Let's turn our attention to the other question though. Which of the elements in our list is going to have the highest third ionization energy? Well, another way to think about this, if the third ionization energy is the highest, what this means is that it was easy, and again, I'm putting this in quotes because we do have to put some energy in, it means it's easy to lose 2 electrons. So in order for an element to easily lose 2 electrons, it's going to have 2 valence electrons. The element that is on the list of having 2 valence electrons is magnesium. All right, so let's take this information and go back to the previous table. And we'll clean it up a little bit. The element that has the lowest first ionization energy, so we're looking at this column, we can see is right here, right? It is sodium. This is exactly what we predicted. And if we turn our attention to the third ionization energy column, we predicted that magnesium would have the highest third ionization energy. And in fact, if we look across the entire column, even though yes, the ionization energy does increase from aluminum to argon, it is magnesium that has the highest third ionization energy because we have to crack into that noble gas core. All right, so whether we are observing first ionization energies, successive ionization energies, or again, electron affinities, we can make similar arguments about whether or not we would expect it to be easy to gain or lose certain numbers of electrons completely based off of electron configurations.